Hello, welcome to Mytechfun. JLC3DP challenged me who can print stronger parts. They are industrial FDM printers, how they claim, versus mine. And to clear immediately, this is not a sponsored video. Yes, the original idea was to sponsoring one of my videos, but I hate ads during the video. Even the YouTube ads during the video are disabled on my channel. But I like this idea and I like challenges. So this means I got these test objects for free, but actually I had to pay some $6 fees or something like that. Probably this is the amount how much I will earn from this video, but I'm not paid anything about this. I could choose the technology and the material, which will be ASA in this case. I prepared some hooks and some bending tests and similar, and then let me show you the ordering process. After the login, I have to upload the STL files, choose the material and technology, and interesting, they have quite strange limitation, 3 by 3 by 1.2 centimeters, so I have to add these elements for the bending test, which will be cut off later, but in this case the system accepts it. And after the upload I can enter some details. Also here I enter the specifications, which are in this case 3 walls and 100% infill. After saving to cart, we can see the automatic estimated price. It is important to mention that they accepted that possibility that maybe my parts will be stronger, but even then I have a permission to publish the video. I ordered some CNC machine parts too, and you can see two boxes because currently you cannot combine these two types of the order. So if you have a 3D printed and CNC machine parts, you have to pay 2 times for the shipping. They're working on the solution, but currently you cannot combine these two types of the orders. Ordering of the CNC machine part is a little bit different because you cannot upload the STL file, but you need, for example, a step file. Here you can see a small example how can you export a step file from the Fusion 360. And also the price estimate is not automatic like with the 3D printing. After the upload you have to wait a few hours during the workday until the objects will be reviewed manually, and then you will get the estimate of the price. Let's take a closer look of the objects. First let's see the 3D printed parts. So these are those test objects, and because of that very strange limitation of 3 by 3 by 1.2 centimeters, I had to add this part to the bending test, which I will remove very easily by cutting in these 2 points. But also on this hook, which was printed horizontally, and the height will be only 10 millimeters, I had to add this element, which I will also cut, but it will not affect the strength of the hook. Now these hooks are printed in horizontal position, this in vertical. I ask for each object to be printed with 3 walls, but this should be printed with 100% infill and the hooks with 30% infill. But I can feel that this is much heavier. I have the feeling that maybe they mixed up. Let me measure them. 35 grams, 20 grams. So maybe they mixed up and they printed this with 100% infill. Unfortunately, I have to wait with printing of my test objects. I will do the testing of these test objects and then I will analyze which settings they used, and then I will print with the same settings my test objects. And now let's see the CNC machine parts. These are holders for the bending test. I already have some kind of holders, but if I want to write some scientific articles in the future, I have to follow better the standard. And the standard for the 3-point bending test, the ISO 178, says that those supports must be rounded with a diameter of 10 millimeters. This is how my setup will look like. So here I place some weight and I will measure the deformation of these test objects. But don't worry, I will keep that old existing supports for the filament testing. Only if I want to write some scientific article, I have to use the new supports. These are made for aluminum 7075, which is harder compared to the regular aluminum. Let's check few dimensions. I asked these 2 dimensions to be equal on both test objects. 2997. 2998, great accuracy so far. I also need this diameter to be 10 millimeters, 9.99, 9.98, great accuracy. Maybe just one more dimension to check. This should be 20 millimeters, 20.06, so a little bit bigger in this case, and this one 20.06. Of course, in this case, I don't need so big accuracy, but it is good to know that in the future, if I will need it, I know the possibilities. Well, it's time to break some plastic. Only I have to print some rings, a distancer, which will keep this hook in the center. And then I will analyze them, how they look like inside, because I want to use the same settings when I print my own objects. These hooks are printed in horizontal position. We will have some kind of bending and tensile stress here. It looks like they are printed as I requested. I can see 3 walls and approximately 30% infill. And these hooks are printed in vertical position, so the layer adhesion is very important here. Well, as I predicted from the weight, they are solid inside, so they are printed with 100% infill. That's fine, but I will print my test objects with the same settings. But this also means that I have to check what is the infill of these S-hooks. Well, with these S-hooks I wanted to have some kind of direct comparison, so their versus mine, but I have to break one to see what is the infill inside. This hook was quite strong and it is solid inside as I requested, so my settings will be 3 watts and 100% infill. It's time to choose my ASA material. It's in a filament dryer now a couple of hours. Let me show it to you. I decided to use 3DO ASA. I checked my summary table from my earlier experiments, and actually this is only the second strongest ASA which I have, but the difference is not too big compared to the first one, and the first one is actually in black color and I want to use different color compared to the JLC3DP. I print my test objects on KIDI X-Max 3, which is not industrial printer, but it is quite good for this kind of purposes. It can heat up the chamber up to 65 degrees Celsius, and I will use the same settings like JLC3DP. I will not even change the flow rate. Theoretically, I could cheat a little bit by changing the flow to, I don't know, 105%, but in that case, I would sacrifice some dimensional accuracy. I try to use the same settings like they did. Of course, I want to print a maximal possible temperature for better layer adhesion, but I don't want to go too high because, for example, those vertical test objects has to be printable even with this printer with the minimal part cooling. ASA is not so sensitive to moisture, but I want to get the best possible result, so it will be dry 2 more hours and even the printing will be from the filament dryer. The first layer is almost finished and soon it will speed up with the second layer. The temperature inside is 60 degrees Celsius already, and they look perfect so far. Even without brim, the objects are perfectly straight, only it's hard to see through this glass. It even have this curve here. Thanks to 100% infill, the layer has enough time to cool down, so this overhang looks okay so far. I'm using here 40% of the part cooling and I hope the layer adhesion will be still strong. So far so good, and I'm very curious tomorrow what will be the result with the mechanical testing. Okay, let's check quickly the weight. This was 35, 26 again a little bit lighter, and 19 again lighter. So my parts are a little bit lighter, 1 or 2 grams. Maybe I should push a little bit more that flow rate. I already checked few dimensions and it looks like their objects are a little bit bigger too. 4.27, 392. $31.9, almost 32, and this I'm curious also about because it's 100% infill. 12.30, it should be 12, and my a little bit smaller. I didn't use any compensation for the shrinking, so or they did some compensation for the shrinking or they use a little bit bigger flow rate. It is 6 in the morning, I woke up earlier because I'm very curious about this test. I already mentioned that I got the permission to publish the video if my parts will be stronger. I forgot to ask them, do I have to publish the video if their parts will be stronger? Anyway, let's continue the testing. I'm starting with horizontally printed objects. It looks like we use a little bit different infill, so this looks denser compared to the mine. But anyway, let's move to the vertically printed objects because there it should be equal, 100% infill. In this case, they look very similar. Only on my test objects in the cross-section I can see some micro holes there where the infill meets the walls. Anyway, let's test the S-hooks now. And now the cross sections are again very similar, but also the brake load, so it will be very exciting that last test where I have two hooks against each other. But before that, 3-point bending test. Now the difference in thickness is almost 0.3 millimeters. We will see how it affects the deformation. This is some kind of aligning holder. Everything will be in the center after this. The load is 2.5 kilograms. And I want to record the deformation after exactly 10 seconds. 1.41. On the second objects 1.4. These are my test objects. 1.42 will be the first one. And 1.4 millimeters the second one. And for the end, I think this will be the most symbolic test, direct comparison between JLC3DP and Mytechfun. And I will not even measure the wake, I will just try to create some kind of slow motion video. This is the regular speed. And this is slow motion. And yes, I was searching half hours until I found all parts. Well, it looks like I lost it, but I can see from these white marks that the difference was not too big and the black test objects was very close to the brake, but yes, between these two, this was stronger. Just quickly to summarize the results, horizontal hook printed with 30% infill, and this is the only test where we can see a little bit bigger difference, but as I mentioned, I cannot measure it, but I can see quite big difference in infill type. The vertical hook, where the layer adhesion is very important, and the difference was very minimal here. And very similar with the S-hook. And this is the result of the 3-point bending test, again very similar values here. But it looks like I lost this challenge, but I think the difference was not so big. I mean, the biggest difference we had with that horizontal hooks with 30% infill, but I think if we would use exactly the same infill, well, in that case the difference would be much smaller. But anyway, the point of this video is actually that if you are not able to print with this kind of technical filaments, or you need something from 3D printed stainless steel, I have a separate video about it. Or you need something from CNC machined aluminum, but in that case it is good to know the possibilities. And JLC3DP has great prices. I mean, for example, the shipping price with DDP parity for these types of objects was bigger than the price of the objects themselves. But you can check the price for your test objects, you can upload them to their system, and you can see the automatic estimated prices, and you can decide if you want to place the order or not. But I hope you find this video informative and interesting, but I learned something from it. And I wish you happy designing and ordering. Bye.